Hi guys, this is Mr. Lawler from Perryfields High School. So I've done a video here of myself making a mind map, and I'm just going to talk over the top of that so that you can see my face talking to you while you read about this. So I'm talking about radioactivity, and I'm going to help you to answer 5 questions about radioactivity today. Sorry, the video's a little bit shaky. I had my camera on a tripod, and when I was writing, it's like wiggling all over the place. Sorry about that. So you're going to get 5 questions about radioactivity. First of all, what is it? What is radioactive decay? And when something decays, what are the 3 types of radiation that they can give off? You need to know about 3 different types. You need to know how those 3 types could change an atom. So when it goes through radioactive decay, what happens? Now I've laid this out as I showed you there, so there's going to be more to know about nuclear equations and about half-life than about the others, so I've left some space there for that. So question 1, what actually is radioactivity? You can go ahead and answer these questions in a book or, on your computer, however you want to do that. Okay, I'm going to give you the answers as well. Alright, so first off, what is radioactivity? It's basically when an atom breaks down. So some atoms are unstable. They can't stay as they are. And so they break down. They stop being what they were and they start being something else. And when they break down, they shoot something out at the same time. So unstable atoms break down. The second question is, so when they break down, what is that actually called? Well, the answer is decay. Okay, so what is it called when atoms break down? It's called radioactive decay. So something that is radioactive is something that can go through this process of breaking down or decaying. Okay, when it does that, that's when it releases that radiation. And it might stop being radioactive at that point, or it might turn into something else that's still radioactive, but it's a different thing. So number 1, what is radioactivity? It's unstable atoms breaking down. When they break down, we call that decay. All right? So there's my first link there. Radioactivity is all about decay. And when they decay, they go into 3 different types of decay. So it could be any one of these 3 types. So our third question is, what are those 3 types of radiation? What are the 3 types of decay that something can go through? So it can go through alpha decay, beta decay, and gamma decay. Now, unfortunately, you need to know the 3 symbols for those. I'm going to draw those on there in a second. Yeah, just make sure I get the numbers. That's super important. Number 1, number 2. So I've got to squeeze that in at the top there. That's a little bit of a squeeze. So 3 different types. Alpha, it looks a lot like a little letter A. Beta looks a lot like a letter B. But it's got kind of like a little sticky thing coming down. And gamma, it's like the Greek letter G. Don't worry about the Greek alphabet or whatever, but it's kind of a squiggle like that. Okay? Now, what are those 3 types? Well, alpha is He. That stands for helium. It's basically a helium nucleus. So an alpha particle is quite big. When something goes through alpha decay, it loses quite a lot. Beta decay is a lot smaller. It's actually like an electron. So if something goes through beta decay, it loses an electron. So gamma decay is just energy. It's an electromagnetic wave. I don't know what I'm pointing at here. I think I'm just recapping what I've already said. So I've said it a few times anyway. I was kind of talking over the video while I did it, but then I thought it's better if you can see my face. So there's the 3 types, alpha, beta, and gamma. Gamma just being the energy. Okay? Now this leads us on to our next question, question 4 being about nuclear equations. So the question here is, when something goes through radioactive decay, how does it change? Or in other words, what is it left with? And as I said, I left a lot more room at the bottom of the page there for myself to write because there's a lot to go on here. So how does the nucleus change when it goes through each of these 3 types of breakdown? It changes in different ways for each one. So for alpha decay first, alpha decay is where it changes the most. Now, because this is an equation, just like in maths, it has to be equal left side and right side. So the arrow shows us what you had before and then what you have after. I like to start by putting in, first of all, the alpha. So alpha has 4, 2. That's just like in chemistry, how you've got the mass number on the top and the proton number on the bottom. So what's on the right is going to need to balance with what's on the left, but what's on the right, we know it has a 4, 2 because it's alpha decay. And in the question, they have to say this is alpha decay, but you always know alpha is 4 too. Okay? Now, I've said element X. This is a generalized thing. Don't worry if the X's confuse you, because I'm going to give you an example in a second. But notice the alpha 4 on the right with the minus 4 balances with what it was at the beginning. Okay? And then if it was B before, then B minus 2 and 2, those balance to be the same thing. So, for example, thorium is radioactive. It can go through alpha decay. Alpha particle is 4, 2. Now, this isn't magic. You don't just need to memorize thorium. Thorium is on the periodic table. So it has a mass of 228, and it has a proton number of 90. So that's what it was before it decayed. So after it decayed, it's lost that alpha particle. That's the alpha particle written separately on the equation line, and whatever it turns into. So what it turns into has to balance, including the alpha particle, with what it was before. So what's 90 take away 2? 88. So 88 and 2 will add up to the same number of protons that it started with. Okay? And you do the same thing with the mass. It has to end up with something that balances when you include the 4 with 228. So the mass number is 224. Okay? Then you take that 88, you look on the periodic table. That wasn't just magic. I had that in front of me. I had the periodic table in front of me. Okay, so you look that up, and then you know straight away that's radon, because radon has 88 protons. Okay, that's alpha decay. That's your first one. When it goes through beta decay, it's a little bit different, but the equation works exactly the same way. It has to balance before and after. So for beta decay, I'm going to use the same symbols here with an X, just saying any element, whatever it is, with a mass number A, proton number B, and then I put in my beta particle. So beta has a mass of 0, it's just an electron, and it has a proton number -1. Remember, electrons are negative, so that's where you get the -1 from. But if you don't understand that, you can just remember that beta is always -1. So -1, to balance, it's going to have to be what it was before +1. Okay, so because it's a -1, -1 plus 1 gives you 0. Okay, so that's where you're going to get it. And again, if that's a little bit confusing, don't worry about it. When you see this example, it's normal. It's not too confusing. So you guys want to see a potassium example? Okay. Potassium's mass number is 40 here, the radioactive one. I'll just put a line in so you can see that that's different. So alpha decay, beta decay, these are totally separate things. Okay, so don't look at that one on the left anymore. Okay, so here's a potassium example. And in the question, they might say, oh, potassium goes through beta decay. So you put in the potassium, they'd give you the mass number, you know the proton number from the periodic table, you write in your beta second. Now that -1 is going to need to balance so that it adds up to the same thing as 19. What could you add to -1 to give you 19? 20. Yeah? What could you add to 0 to give you 40? 40. So the mass number of whatever it becomes, so potassium was radioactive, is going to decay, letting out a beta particle. And when it does that, it's going to end up as calcium. Why? Just because you had 19 before, you lost a -1, that balances out if you put 20. Okay, so potassium actually turns into calcium if it goes through beta decay. So here's my overalls. How does the nucleus change? This is question 4. If it goes through beta decay, it will end up with the same mass, and it will have an element that is 1 higher on the periodic tables because it has a proton number +1. Yeah, an alpha particle, if it goes through alpha decay, the nucleus changes because it loses a mass of 4, and it loses 2 protons as well. So the helium particle takes two protons, 2 neutrons with it. That's why you lose a mass of 4. Okay, so there's alpha decay, beta decay, and gamma decay. Gamma decay, how does it change? It doesn't. Essentially, it doesn't change. It loses a little bit of energy, remembering that gamma is an electromagnetic wave, so it's not taking any mass with it, so the nucleus stays the same. Okay, beta decay, it changes. Alpha decay, it changes. And gamma decay, it doesn't change. Now the last one, this is a big one. A lot of students get stuck on half-life. What actually is half-life? It essentially just means how quickly does something break down. If it has a really long half-life, it's going to stay radioactive for a long time, but it's not releasing that much radiation. If it has a really short half-life, it means it's going to keep cutting in half really quickly. It's going to decay really quickly. So here's your answer. What is half-life? It tells you how quickly something decays. So if that number is really small, then it's going to decay really quickly. If that number is really big, and it's a time, okay? If it's a long time, then it's going to take a long time for it to cut in half-life. Now, how does this actually work out in terms of what are the questions that they would ask you for this? There's two types of questions, so I'm breaking them down separately for you. And I think I'm going to need to move my head here. So I'll just go smaller. Boop. There we go. Go a little bit smaller. I'm still here. So two types of questions. Otherwise, I was going to run out of space on my screen there. First type of question would be, how many radioactive atoms are going to remain after blah, blah, blah time? Now, for this type of question, they will tell you what the half-life of this thing is. And they have to tell you how much time is passing. Okay, so you don't need to work out the half-life in this one. You need to work out how many are there if you know what you started with. Okay, so they'd give you this information in the question. They'd say, okay, substance has, radioactive substance has a half-life of, say, 1 hour. Yeah, and how many of them are going to be left after 3 hours? Okay, and then they have to tell you, the only other thing they still have to tell you is how many did you start with. If you don't know that, then you don't know how many, you can't work out how many you end up with. So if you start with 8 million, you have to think about sort of cutting it in half, because half-life always works with halves. So if you start with 8 million, think about what would be left after you cut it in half. 8, 4 million. Now, how long did it take to cut down into 4 million? That's one, it takes one half-life. What is the half-life? It's 1 hour. Okay, they told you that in the question. So that means 8 million goes down to 4 million in 1 hour. So is it going to lose another 4 million in the second hour? That's where a lot of students go wrong. No, it's going to go from 4 million, it's going to lose 2. So it's going to go down to 2 million after the second hour. After the third hour, it's going to lose another half. It's going to go down to 1 million. So a question like this, they tell you how much you started with, they tell you how much time has passed, you have to work out how many are left after that amount of time. That's 3 half-lives, so it's cut in half 3 times. 8 to 4 to 2 to 1 million. Okay, so that's question A. That's the first type of question they can give you about half-life. How many radioactive atoms remain after such and such time, and they told you the half-life. Okay, you can work that out, no problem. So notice that because it was an hour, it is still quite a lot left after 3 hours. Now the next question I'm going to give you, this one's got a different half-life. Okay, every radioactive substance has a different half-life. They're all unique. Okay, so this type of question, you have to work out the half-life, but they tell you how much you start with and how much you ended with. Okay, so I'm going to give you some nice round numbers here, 50,000. So that's how much you start with. And those are unstable. That tells you it's going to go through radioactive decay. Notice they're not telling you alpha, beta, gamma. It's nothing about that. You don't need to know which type of decay. All you need to know is the half-life and the numbers of things. Okay? So because you started with 50,000 atoms, and 10 minutes later you have 12,500, it's saying, what is the half-life? Well, hopefully you can see the connection between those two numbers straight away. I tried to make it easy. It's not going to be super difficult. They shouldn't ask you at GCSE to be doing any serious rounding or things like that. Just work with pretty obvious numbers. Okay, so from 50,000 down to 12,500, it's got to cut in half twice. So that means that the time that's passed from the start to the finish has got to be 2 half-lives. That's why I've drawn 2 red arrows here. So from 50,000 to 25,000 was 1 half-life. And from 25,000 to 12,500 was 2 half-lives. That took 10 minutes total. So each half-life was the same amount of time passing. That's basically 10 minutes cut in half. That's, let me just move over a bit. That's 5 minutes as your half-life. Okay, all right. So that's your half-life is 5 minutes for this one. That's the second type of recap. Let me move my face out of the way here. Okay, so I'm doing a recap of everything here. What is radioactivity? It's when unstable atoms break down. And what do you actually call that breakdown? You call that radioactive decay, where the nucleus is changing from what it was into something else. When it does that, it can go through 3 different types of decay. alpha, beta, or gamma. Alpha being a helium nucleus with a big mass, beta being an electron, and gamma just being some energy, an electromagnetic wave that gets shot out of the nucleus when it decays. Okay, so how does the nucleus change? So for alpha decay, beta decay, and gamma decay, I'll go through gamma first. That was the easiest one. So the nucleus stayed the same for that one. Whereas for alpha decay, it lost a mass of 4 because the helium nucleus took 4 things with it, and it changed by a proton number of 2. Beta decay, it stayed with the same mass because the electron didn't have any mass, but it went +1 on the element scale. So it went from 19 to 20. Okay? I'm not sure why I'm pointing at thorium and radon, but just remember that those things balance. Okay, the last one was about half-life. What is it? It tells you how quickly something decays. When it's smaller, it decays quicker. When it's longer, like the 1 hour example up at the top there, it didn't lose all of it even after 3 hours. So remember, you can work out how much is left if you know the half-life. If they ask you a question like that, or in question B there, they tell you what you started with. They tell you after a certain amount of time how much is left. You can work out the half-life. Okay, so in our example there, we worked it out. The half-life was 5 minutes because it chopped in half twice in that 10-minute span. And that's the end of my video there. Okay, so I hope that was really useful for you guys, and I hope that you can use that when you're in lessons or if you're doing your revision at home. Make sure that you've answered those 5 questions, and I'll drop that in the description below. Great, have a great day.